Hi, my name is Samuel, and this is a video about my experiences in robotics and computer science. Getting to know robotics traces back to 2018, when I saw the first tech challenge in Shenzhen. I was infatuated by how the players controlled the robot on the court, and just then I thought that I'll never be doing something else apart from this. From that time on, I started to pay attention to videos and articles released about FTC and everything else that is related to FTC. In the middle of 2019, I joined the Science Robotics Club, and that is where my robotics life started. Because I participated in systematic Python and C++ coding courses for nearly 3 years, I became part of the core design group of the Science Robotics Club when I first joined. In July 2021, our team fought into the Shanghai finals and was awarded the Think Award because of the outstanding design and structure of our robot and the excellent capabilities it had. Although being awarded the Think Award is absolutely fantastic, what I think is more important is the growth of my skills that these experiences burnished me. Below, I will use the actual case we're dealing with in the 2022 season to give you an elaborated explanation. First of all, I have excellent strategic cognition. Let's take the FTC 2022 season as an example. The main purpose of this season is for robots to pass an obstacle, pick up freights, and lay them down in an assigned area to score. There is an obstacle put in place on purpose to increase the difficulty of the competition. I believe the majority of the teams will be misled by the regulations of the obstacle, thus taking a strategy of overcoming the obstacle to score. This strategy seemingly solves the problem we face, but in fact, it raises the cost of designing and building the robot while also superimposing risks on top. This can be for the following two reasons. Firstly, the robot colliding with the obstacle will make the robot shake violently, thus increasing the risks of hard disks and other components inside the robot disconnecting. Furthermore, because the obstacle is consisted of two big plastic pipes, going over the obstacle back and forth will mean the wheels of the robot hitting the obstacle multiple times, wasting a lot of time. As a result, the amount of chances that the robot may score is vastly decreased. Facing this situation, I have a better solution. I choose to compress the width of the robot so the robot can go through the space between the obstacle and the edge of the court. There are some benefits of this strategy as the following. First of all, this avoids the robot hitting the obstacle, decreasing the risks of hardware disconnecting. Secondly, the robot does its work more efficiently on flat land. And thirdly, along with the help of the horizontal rail, we will be able to moreover increase the efficiency of our robot scoring. However, every strategy is like a double-sided coin, where no tactic will be perfect. This may lead us to the question, what if the road we're taking is obstructed? We have considered this question before we designed the robot. In this case, our robot can go to the shared shipping hub to score. As long as we and our teammates sort out the working together, we can avoid the collision. On top of that, through remodeling the structure, our robot is able to decrease the distance of it carrying the freight again by accessing the rotation device and the horizontal rail simultaneously. Secondly, I have modular design awareness. During the process of designing the robot, I shared my thoughts with my team. I separated the robot into 4 main parts. First of all, the chassis, designed to let the robot pass through the space between the obstacle and the side of the court to transfer freights. The second part is the intake and release device, designed for taking in and releasing freights. The third module is the horizontal rail, which is able to prolong the distance the intake and release module could reach. Last but not least is the rotation module, aiming for the fast movement of the freights. After modeling and testing for the extremes of the prototype robot with my friends, part of the suggestions and designs I gave out is accepted by the structure group. During my FTC education, I accumulated rich Python and coding experiences. After I joined the Science Robotics Club, I self-studied the Java language and became familiar with its basics from the documents and videos online. In the same time, by complementing the software and hardware, I systematically studied the overall structure of a robot. I learned how to use motors, servos, sensors, and controllers. and later on used these techniques to program a teleop algorithm of my own. In 2021, my coach showed me a video of the foreign team 11115 scoring in the autonomous period. I was deeply fascinated by the swift and fluid movement of their robot. My coach told me after this that they used a technique called odometry, an accurate locating technique involving 3 encoders, designed to spot and note down the position change of the robot in a very short period of time, then taking this change and calculating the current position of the robot. I was obsessed with this skill right at that point, and I set a plan for myself to learn how to use this technique, and then go deeper and find the mysteries behind. When time grew by from materials posted online, I found that odometry involved a lot of background knowledge, such as Cass's motion model, PID control, trigonometric functions, etc. When I am able to fundamentally master the use of odometers, I stepped on the course of finding how odometry works. Although I still hadn't fully understood this technique, I believe I'll be able to do so in the near future. Finally, I have the spirit of not giving up. In the 2021 Shanghai National Championship, we didn't perform pretty well in the first few rounds of qualification match. So after the matches are finished, we didn't fight into the first 10 places, and my teammates were very depressed. However, the first slogan, "Gracious Professionalism," guided me. I thought that I should do everything to push us into the finals. As a result, I gathered everyone together and led them to the resting spots of other teams and tried to sell us to them. Although in the end we were not chosen, but I've tried hard, and I'm not regretful of what happened. I am proud that I persisted. Thank you for watching this video. I believe I have the skills to lead a team, as well as my own insights into structural design, program design, and strategy. I sincerely hope that I could have the opportunity to unleash my talents. Thank you.